Now for 11.7, we're going to learn something more about parabolas and their application. So first of all, what we call to find the vertex. We talked about before how to complete the square. So that's exactly what I'm going to do. I'm just going to write that f of x is going to be x squared minus 4x, and my plus 5, I'm going to throw it way over here. I remember we used to do the plus 5, I used to move it to the other side. That's when we used to solve. But in this case, because I don't have a number on the other side of the equal sign, I can't move the 5. I'm just going to move it to the side. I ask myself, what's the half? Well, first of all, my first number, the one in front of the x squared, has to be a 1. If it is not, divide everything by that number. Now, because it is a 1, I'm thinking, what's the half of negative 4? Because that's my second term. I ask myself, what's the half of negative 4? So that gave me a negative 2. Square it. What's negative 2 squared? Right, negative 2 times negative 2 is positive 4. So what I'm going to do, I'm going to add a 4, and then I'm going to subtract the 4. By adding a 4 and subtracting a 4, technically I don't change the values. But the reason why I did that is, when I look at this, x squared minus 4x plus 4, if I was to factor it, that would give me x minus 2 squared. So I have that f of x is x minus 2 squared. That's what gives me the parentheses, right? I completed the squared. Now, outside of the parentheses, I have a negative 4 plus 5. So that gives me plus 1. Now, the vertex, the reason why we want this, because the previous section, we said that the vertex, this is my x value, just opposite sign. And this number at the end, that's my y value. So find the vertex of this graph. I'm just going to say the vertex is positive 2, positive 1. Remember, inside of the parentheses with squared, that's my x value, just opposite sign. My y value is at the very end, outside of the parentheses. Sometimes there might be a number here, the very beginning, that has nothing to do with my vertex. That's just the aperture. So you guys try this out. Try to complete the squares, and your answer should be that. Now let's take a look at this one. Find the vertex of the graphs. So I'm just going to say, first of all, I'm just going to say that f of x is equal to, because I'm going to do negative 3x squared plus 6x, and then my minus 1, I'm going to throw it way over there. Now my first number is not a 1. So what I'm going to do, I'm going to divide by a negative 3. I'm going to factor out the negative 3. I'm just going to be dealing with the first two terms only. I'm going to factor out the negative 3. So that gives me x squared minus 2x. And then once again, I have my minus 1 at the very end. Just looking at the parentheses. Okay, my first number is a 1, which is good. Then I ask myself, what's the half of negative 2? That's a negative 1. Square it. Negative 1 times negative 1. Right, because I'm going to square that. That gives me a plus 1. But when I add something, I must make sure that I subtract it. However, this is not just a 1. Because this 1, with the negative 3 multiplied outside of the parentheses, I added a negative 3. Right. 1 times negative 3 is negative 3. So I added a negative 3. To compensate, let me add a positive 3 outside of the parentheses. So what I have is x minus 1 squared with a negative 3 on the outside. So I have that f of x is negative 3, x minus 1 squared plus 2. My plus 2, because I combined this, positive 3 minus 1. My vertex in this case, you guys can see it there. It is, my vertex is 1, 2. Remember I said this is my x value, just opposite signed. And I said this is my y value. My number at the very front of my parentheses has nothing to do with my vertex. My vertex is 1, 2. You try these out, and that's what you should get. Now there's another formula. For us to get, having our f of x as ax squared plus bx plus c, so having the values of a, b, c, for us to be able to find the x value, because sometimes it's not going to be easy to complete the square, for us to be able to find the x value of the vertex only, so keep in mind the x value only, I'm going to use the formula x equals negative b over 2a. That's going to give me the x value of the vertex. To find the y value, I'm going to plug in the x on my function, and that's going to give me the y value. All right, so what I meant with that is, remember I just said x equals negative b over 2a. Like, so we can try completing the square if we want to, but another way we can do it is by doing this. I can tell my a is 1, my b is negative 1, and my c is negative 6. So my x value of my vertex is negative b over 2a. So negative of a negative gives me a positive. 2 times a gives me 2. So my vertex, my x value is 1/2. So I already know half of my answer. 1/2. That's the x value. I need to figure out my y value. Now for my y value, what I'm going to do, I'm going to use the function that I have, but I'm going to use the value of x that I already have. What I mean with that is I'm going to go 1/2 squared minus 1/2 minus 6. I'm using the function, it's just that I am using the value of x that I just found out. I know 1/2 squared is 1/4. So I have 1/4 minus 1/2 minus 6. All right, let me combine my first two numbers. 1/2, let me write that as 2 over 4. Let me just combine my first two numbers. 1/4 minus 2/4, that is negative 1/4. Minus, now my 6, let me write that as 24 over 4. So this gives me negative 25 over 4, and that's my y value. That's my vertex. All right, we can do completing the square, like we did in the first two examples, or we can use this formula. X equals negative b over 2a gives me the x value. Plug in the value of x in your function to find out the y value. You try these at home. That's what you guys should get. Now, if the numbered outside of the parentheses, my a, my first numbered, is positive, I know the parabola opens up. If my a is negative, I know my parabola opens down. You should be able to find your vertex. Now let's talk about finding the intercepts, and then we should be able to complete the graph. So looking at this, I know I can find my vertex, x squared minus x minus 6. That looks very familiar. X squared minus x minus 6. Found that my vertex was 1/2 minus 25 over 4. So find your vertex however you can. And we found that it was 1/2 minus 25 over 4. Which is rough. 1/2 is in decimals about 0.5. We can do that easily. Now, negative 25 over 4 is about negative 6.25. So that's roughly somewhere about here. That's my vertex. Now let's talk about my first number. It's a 1. It's a positive 1. So I know this thing opens up. Okay. Another thing I should be able to find out is my intercepts. I'm going to factor it. X squared minus x minus 6. Remember how we used to factor this? I get x minus 3, x plus 2. I factor it. We remember how to factor it. You let each of your factors equal to 0. X minus 3 equals 0. X plus 2 equals 0. So I get that x is equal to positive 3, and I get x equals negative 2. Now those values, positive 3, negative 2, are the values where I'm going to intersect the x-axis. So I have a vertex. I know it opens up. I know where I cross the x-axis. I can say I have a very good idea how my graph looks like, and that's my graph. Find your vertex. Find your aperture, whether it opens up or down. Find your intercepts, and you're good to go. You should be able to try these. We'll try this one. There's your vertex. You can see your vertex. You can see your intercepts. Now, our discriminant. Our discriminant tells us a big thing. How many times we're going to cross the x-axis. If our discriminant is a positive, so if our discriminant is more than 0, when I talk about discriminant, I'm talking about b squared minus 4ac. If this is more than 0, I'm going to cross the x-axis twice. All right, for example, my discriminant was 49. If I was to ask you, what's the square of 49? You could think, positive 7, negative 7. So it has 2 possible values. So it gives me, I'm going to be able to cross the x-axis twice. If it's up and down, this is how the graph might look like. If it's up and up, this is how the graph might look like. Either case, you're crossing the x-axis twice. Now, if your discriminant is equal to 0, you're going to touch the x-axis only once. If it is up and up, that's an example. See how it touched the x-axis once. If it is up and down, there's another example. Now, if the discriminant is less than 0, that means you don't touch the x-axis. If my graph is up and up, there's an example. If my graph is up and down, notice how neither of them touch the x-axis. So the discriminant tells me how many times I'm going to cross the x-axis. Let's take a look at this one. Use the discriminant to determine the number of x-intercepts of the graph for each quadratic function. Remember, my discriminant is b squared minus 4ac. I know my a is 2, my b is 3, and my c is negative 5. So I'm looking at 3 squared minus 4 times 2 times the negative 5. I know 3 squared is 9. Those two negative signs make a plus sign. 4 times 2 times 5 is 40. So I'm going to say my discriminant is 49, which is a number more than 0, right? It says I'm going to find out my discriminant is 49. How many times am I going to cross the x-axis? I'm going to say 2 intercepts. I'm going to cross the x-axis twice because my discriminant is a positive number. Let's take a look at a couple more examples. You guys might be like, well, I don't have an x. I just have an x squared and then a negative 1. I don't see a term with an x. Let me rewrite this as negative 3x squared plus 0x minus 1. I need to have all 3 terms. So I'm just going to say that my a is negative 3, my b is 0, and my c is negative 1. Remember, I'm looking at b squared minus 4ac. So I have 0 squared minus 4 times a negative 3 times a negative 1. So 0 minus, because I know these two negatives made a positive, but minus 4 times 3 times 1 is 12. 0 minus 12 is negative 12. My discriminant is negative. So I have no x-intercepts. Take a look at example C. My A is 9, my B is 6, and my C is 1. Remember, I'm looking at the formula b squared minus 4ac. So I have 6 squared minus 4 times 9 times 1. I know 6 squared is 36 minus 4 times 9 times 1 is 36. 36 minus 36 is 0. When my discriminant is 0, I get 1 x-intercept. Here it is for you guys to try at home. I gave you guys your discriminant, the value of the discriminant, and whether it was 1 x-intercept, no x-intercepts, or 2 x-intercepts, based on your discriminant. Now, the quadratic function to solve problems involving maximum and minimum values, the y value of the vertex gives me the maximum or minimum value of y. The x value tells where the maximum or minimum occurs. This is very important. Very, very important. So looking at this, it says a farmer has 120 feet of fencing. So I'm going to build a fence. I only have 120 feet of fencing to enclose a rectangular area next to a building. So you guys see my shape here. I'm only going to build 3 sides since one of the sides is the building. Find the maximum area he can enclose and the width required to produce this maximum area. So I'm going to say the width, I don't know what it is. We're calling it an x. Now, because I only have 120 feet of fencing, you notice here I have 120 feet minus 2x, which is basically the 2 x's that I already used. For the area of a rectangle, don't I have to go length times width? So 120 minus 2x times x, right? Length times width. So that gives me the area of my rectangle is 120x minus 2x squared. Let me rearrange things a little. I'm going to write this as negative 2x squared plus 120x. I'll even add the plus 0, so just that way I have a trinomial. I'm going to find my vertex. Remember, I used to do the formula x minus b over 2a. That gives me my x value of my vertex. So I'm just going to say negative 120 over negative 4. Notice that my b is 120, so the negative of b is negative 120. I have to go 2 times a. That's what I got, the negative 4. All right, so negative divided by negative is positive. 120 divided by 4 is 30. So my vertex, I know my x value is 30. I'm going to use this formula, this function right here, to find my y value of my vertex. So I have that negative 2 times 30 squared plus 120 times 30. I don't have to do the plus 0. All right, 30 squared, right? 30 times 30, isn't that 900? 900 times a negative 2, that's a negative 1800. Notice I did the square first. I have to do exponents before I multiply. Plus 120 times 30. That gives me 3600. Now, negative 1800 plus 3600, that happens to be 1800. So I found my vertex. Very important. I put the box because it's very important. Let me go one slide back just to remind you guys of something that I just said on vertex. The x value tells where the maximum or minimum occurs. The y value of the vertex gives the maximum or minimum value of y. Okay, so here, the area, the maximum area that I can do is going to be 1800 feet squared. When does this occur? Because remember, the y value told me that the biggest value. When does this occur? When x is equal to 30. When the width is equal to 30. So as a matter of fact, let me put. Remember how the width, I called it x? So find the maximum area he can enclose and the width required to produce this maximum area. Vertex helps us out. Be careful when interpreting the meanings of the coordinates of the vertex. The first coordinate, the x value, gives the value of which the function value, y or f of x, is a maximum or minimum. So let's take a look at this one. If air resistance is neglected, a projectile on Earth shot straight upward with initial velocity of 40 meters per second will be at a height s in meters given by a formula. So this formula tells me the height of the object, where t is the number of seconds elapsed after projection. After how many seconds will it reach its maximum height, and what is this maximum height? So let me find out what my vertex is. I know my x value. Remember, I have my formula, s of t is negative 4.9 t squared plus 40t. I'm going to say my a is negative 4.9 and my b is 40. And the reason why I need this is because I know my x value is negative b over 2a. So I have that negative 40 over negative 9.8. All right, so negative 40 divided by negative 9.8. I'm going to say this is roughly 4.1. So for my vertex, I need to find out my vertex. It's about 4.1. My x value. Now for my y value, I'm just going to use negative 4.9 times 4.1 squared plus 40 times 4.1. If you notice, I'm using this formula. I know the value of t now. Now, 4.1 times 4.1 is 16.81. So I have negative 4.9 times 16.81 plus 40 times 4.1. All I did was my exponent. All right, 16.81 times negative 4.9. I have this is negative 82.369. 40 times 4.1 gives me 164. This says is 81.631. All right, so I'm just gonna say the y value. It's about 81.6. I'm gonna run it up to 81.6. So that's my vertex. Very important thing. So now after how many seconds will it reach the maximum height? After 4.1 seconds. What is the maximum height? 81.6 meters. Notice I'm reading that from my vertex. Now we're going to use parabolas that are open sideways. Before, when we had the y equals, ax squared plus bx plus c, the parabola was open up or down. But now, when we have the x by itself, notice I'm switching the values of x and y, it's going to open sideways. Now, it is interesting. If I complete the square, before, inside of parentheses, we will get the x value, and outside of parentheses, we'll get the y value. Interesting part here is this number outside is my x value, as it is. This number on the inside is my y value, opposite sign. So that's how I'm going to find my vertex. My axis of symmetry is the horizontal line y equals k, which is my y value of my vertex. If my a, my first numbered, is more than 0, my graph opens to the right. If my a is less than 0, my graph opens to the left. All right, so let's take a look. So I have this, and it says graph this. So a couple of things I'm going to do. First of all, I want to know my vertex. My vertex happens to be -3, 2. Remember, I came in and said this is my x value. Do you see -3? Remember, I said this is my y value, opposite sign. So my vertex is -3, 2. My number in front of the parentheses at the very beginning technically is a +1. It is positive, so it opens to the right. So I have this. So I'm just going to say, well, I know the vertex is -3, 2. It opens to the right. Let's find another point. Let y equal to 0. I'm going to use my function. Let y equal to 0. So if you notice, I have the function x equals -2 squared minus 3. And I call it -2 since I said y equals 0. 0 minus 2 is in that -2. All right, so I have that x is equal to 4 minus 3. So I get that x is equal to 1. That means the point that I just found is the point 1, 0. Remember how I said let y equal to 0? We just found that x is equal to 1. So I have the point 1, 0. All right, so remember, this is my vertical line where things get reflected. We call this the axis of symmetry. Notice how my point that I just found, 1, 0, is below my axis of symmetry. I'm going to put it 2 above. I just found that. I have a very good idea how my graph looks like. I'm just going to connect my points. Find your vertex. I had an idea that my graph opened to the right. I found another point. It is on one side of the axis of symmetry, so I just copy it on the other side. Only quadratic equations solved for y whose graphs are vertical parabolas are examples of functions. Now these examples that I just have here, this one, We don't call it a function. We just call it a graph. Now this is for you guys to try. Find your vertex. And it's open to the right. Find an extra point. Just to help you guys out, your vertex is -4. Remember, that's my x value. So -4. Now my y value is right here, but it's just opposite side. So I'm going to say -4, -1. That's my vertex. It is open to the right because at the very beginning, it's a positive sign. So it is open to the right. I imagine this as my axis of symmetry. I'm going to find another point. I'm going to let y equal to 0. Why am I letting y equal to 0? Because 0 is easy to deal with. You let y equals whatever you want. So I'm just going to say x equals, remember I said y equal to 0. So I get 1 squared minus 4. So x equals 1 minus 4. That means x equals -3. My other point that I just found is -3, 0. So I'm going to say there's another point as well. So notice I found the point -3, 0. But I copy it the same on the other side of the axis of symmetry. We could have let, y equals whatever we wanted. But let's see, we have a good idea how the graph looks like. And that's how it should look like. Now, once again, where the y was by itself, that my graph opened up or opened down. It was a parabola. We call it a function. It was open up or open down. Now, when the x is by itself, it's either open to the right or open to the left. Open to the right if my a is more than 0. Open to the left if my a is less than 0. And these graphs are now called functions.